Welcome to the world of machine learning and mobile app development. Whether you want to train machine learning models or you want to deploy them in mobile applications, you are in the right place. My name is Muhammad Hamza Asif and I am a leading mobile machine learning instructor at Udemy. And in this course, I am going to take you through an exciting journey of training machine learning models and integrating them into mobile applications. Inside this course, you will learn to train linear regression, image classification, and object detection models from scratch. After that, you will learn to optimize these models for mobile using TensorFlow Lite. And finally, you will learn to use these models inside mobile applications using different mobile app development frameworks like Flutter, native Android, and native iOS. So by the end of this course, you will have mastered the entire workflow from training machine learning models to using these models inside mobile applications. So whether you are completely new to mobile app development or machine learning, or you are a developer looking to integrate AI into your applications, or a data scientist or machine learning engineer wanting to take your models mobile, this course is for you. So what are you waiting for? Join the course now and start your mobile ML journey today. So now let's look at the course curriculum. So we will start by learning the basics of machine learning and its types. After that, we will learn about deep learning and artificial neural networks using which we are going to train our models. Then there will be a crash course on Python programming language because using Python we are going to train our ML models. After that, we will learn about different data science libraries like NumPy, Pandas, and Matplotlib, and these libraries will help us to prepare and analyze datasets for model training. And then you will learn about TensorFlow and TensorFlow Lite. So by using TensorFlow, we are going to train our deep learning models, and using TensorFlow Lite, we are going to convert and optimize these models for mobile applications. So after learning everything which is required, you will learn to train machine learning models. So firstly, you will learn to train a very simple linear regression model and convert it into a mobile compatible format using TensorFlow Lite. After that, you will learn to train advanced linear regression models on real-world datasets to predict fuel efficiency of automobiles and prices of houses. And after linear regression, you will learn to train image classification models on your custom datasets. So in this section, you will learn to collect and organize datasets for model training, and then you will learn to train image classification models using two different approaches. And after image classification, you will learn to train real-world object detection models. So in this section, you will learn to collect and annotate datasets for model training, and then you will learn to train object detection models on these datasets. So after training machine learning models, you will learn to use these models inside mobile applications. So inside this course, we will be using 3 different mobile app development frameworks to build our mobile applications. And these frameworks include Flutter, native Android with Kotlin, and native iOS with Swift. So throughout this section, we are going to use our custom trained machine learning models inside mobile applications. And we are going to build exciting applications like a fuel efficiency prediction application, a house price predictor, a fruits classification application, a flower recognition application, a brain tumor detection application, and a fruit detection application. So after completing this course, you will be able to train your custom image classification, object detection, and linear regression models, and you will be able to use them inside both Android and iOS applications. Welcome to this lecture. In this lecture, we will look at the basic introduction of machine learning. Machine learning is a branch of AI and computer science which focuses on the use of data and algorithm to imitate the way humans learn. So the basic idea is you supply data to computer and computer finds pattern in that data. And then based upon that pattern, computer can make predictions. So let's understand machine learning with the help of a simple example. So suppose that we want to train a machine learning model to recognize different breeds of dogs. Like we want to recognize German Shepherd, Afghan Hound and Pointer. So to train a machine learning model which can recognize these three breeds, we are going to collect the images of these dogs. And this process is called data collection. So after collecting few images of German Shepherd, Afghan Hound and Pointer, we are going to pass these images to our machine learning algorithm. And now this algorithm will gonna find pattern in these images and we will get our trained model. And now in this trained model, there is a specific pattern for each breed of dog. Like there will be a specific pattern for German Shepherd and there will be specific pattern for Afghan Hound and Pointer. And now when we are going to pass an image to this trained model, then based upon the pattern which this trained model contains, it will gonna make a prediction that German Shepherd is present in the following image. And it is possible because our model knows the pattern for German Shepherd. And our model predicted that because we trained our model on images of German Shepherd. So now when we pass this image to our model recognized the breed of that dog and given us the result. So that is the process of training a machine learning model. Similarly, let's look at another example. So let's say we want to train a machine learning model to predict the salary of a person based upon his experience and certifications. So to do that, we are firstly going to collect the dataset, and now the datasets will gonna consist of the experience, certification and salary of different persons. So after getting the dataset, we are again going to pass it to our machine learning algorithm. And now our machine learning algorithm will gonna find the pattern and we will get our trained model. And now in this trained model, there is a specific pattern using which our model can predict the salary of a person given its experience and certification. So now when we are going to pass the experience and certification for this person, our model will gonna make a prediction for the salary. So as I mentioned earlier that you supply data to computer and computer find patterns in that data, and this process is called machine learning. So here we supplied this data and our algorithm found a pattern, and now based upon that pattern our trained model can do predictions. So now let's look at the types of machine learning. So there are three main types of machine learning: supervised machine learning, unsupervised machine learning and reinforcement learning. And we will cover the basic introduction of all these three, but before that we need to look at few machine learning terminologies which will gonna help us understand these types better. And the first term is dataset. So as the name suggests, dataset is a collection of data for training our machine learning model. And this data can be in the form of images, text, audio and so on. So as we have seen the example of training a machine learning model for predicting the salary of person based upon his experience and certifications. So to train this model, we firstly need to collect the data of few persons. Like we are going to collect the experience, certification and salary of a number of people. And the process of doing this thing is called dataset collection. And after collecting that data, we split that data into multiple parts. But the main two parts are called training data and testing data. So as the name suggests, on training data, we train our machine learning model. And on testing data, we test our model after training. And as inside this dataset, we are predicting the salary of a person based upon experience and certification. So here our output or predicted value is salary. So we also call the column which we are predicting label. And the columns using which we predict this label are called features. So these are few terms which you need to keep in mind while understanding the types of machine learning. So the first term is the label, so it is actually the value which we are predicting. And then there is a term called features, so this is basically the columns or the values using which we are making the prediction. So now let's look at the first type of machine learning, which is supervised machine learning. So in supervised machine learning, label data is used to predict a label given some feature. So what does that mean? So it means that while training a supervised machine learning model, we use such dataset where we got both features and label. Like this dataset for predicting the salary of a person contain both features and also the label. So now in supervised machine learning, we are going to pass both of these features and also this label to our machine learning algorithm. And now our algorithm will gonna find the pattern based upon these input and this output. And after that we will get our trained model. So as the label is also there in this dataset, so this dataset will be called a labeled dataset. So hopefully you are getting the point that in supervised machine learning, we train machine learning model on questions and also on answers of those questions. And then we ask model to give answers of similar questions. So in supervised machine learning, when we are going to train our model on this dataset, firstly we are going to divide our dataset into these two parts. So on training data, we are going to train our model, and then for testing our model, we are going to use this testing data. So here we are only going to pass the experience and certifications to the model, and our model will gonna predict the salary of a person. If you want to become a mobile machine learning expert, then subscribe to this channel and get 92% off on our mobile machine learning courses. Links are given in the description. And now let's look at the types of supervised machine learning. So there are two main types of supervised machine learning. The first one is regression and the second one is classification. So as in supervised machine learning, we are predicting the label based upon the features. So if our label is continuous, then it's called a regression problem, and if our label is categorical, then it is called a classification problem. So as we are predicting the salary of a person based upon his experience and certifications, so here the value of salary is continuous because it can be any value. So that is called a regression problem. On the other hand, if we are predicting the gender of a person based upon his height and weight, then we are predicting a categorical value because gender can be either male or female. So here this problem will be called classification. So in simple words, in supervised machine learning, if we are predicting a continuous value, then we are dealing with the regression problem. And if we are predicting a categorical value, then it is a classification problem. So now let's look at regression. So in regression, trained model is used to predict continuous numeric value. So for example, if our task is given experience and certification of person, predict his salary. So here our features are experience and certification of a person, and our label is salary. And as salary can be any value, so it is a regression problem. On the other hand, in classification, our trained model is predicting classes or categorical values. So for example, given a person's height and weight, predict their gender, which is either male or female. So here our features are height and weight and our label is gender. So as this gender can be either male or female, so it is a categorical column. So here our label is categorical value, so it's a classification problem. So now let's look at unsupervised machine learning. So in unsupervised machine learning, we use unlabeled data to train our machine learning model. So unlike supervised machine learning, we don't have a resultant value, we just have the input data and we need to find pattern in that data. So we give that unlabeled data to our algorithm to train a model, and then we ask questions from that model. And the example of unsupervised machine learning is clustering. So let's look at the detail of clustering so that we can understand that how machine learning models are trained without the label or without the result. So clustering is a method of dividing objects into clusters or groups that are similar between them and are dissimilar to the objects belonging to another cluster. So for example, finding out which customers made similar product purchases. So the practical example of clustering can be applied on a bakery or on a store. So if we got the data about the purchases of the customers, then after passing this data to our unsupervised machine learning algorithm, we can get useful outputs. Like here, if on a bakery, a customer bought these items, which are bread, milk, fruits and wheat, and then customer 2 bought bread, milk, rice and butter. So here, based upon our observation, we can see if the customer has bought bread, then he is most likely to buy milk too. And same is the case with thousands of other products. So after getting the data of a lot of customers and passing it to our algorithm, we can get to know that which items are bought frequently together. And then based upon the results, we can position them correctly inside our store so that customer will find these items with ease and he is most likely to buy them. And now let's look at the third type of machine learning, which is reinforcement learning. So it is actually a branch of machine learning that allows an AI-driven system or an AI agent to learn through trial and error using feedback from its action. So what is the mean of this long statement? So it means that inside reinforcement learning, our AI model or agent perform few actions, and then based upon the result, our model or our agent learns that whether that action is right or wrong. And the example of reinforcement learning is robotic dogs, self-driving cars and so on. So for training self-driving cars or even robotic dogs, they are being put in an environment where for each action they perform, they will either get a reward or a penalty. So now by performing a lot of actions and getting the output, they learn that by performing which action they will get the reward, and they are more likely to perform these actions in future. So by that way our model is trained, or they learn that which action to perform. So reinforcement learning is a short form of trial and error method. Welcome to this lecture. In this lecture, we are going to learn about deep learning and artificial neural networks. So let's start. Deep learning is a subfield of machine learning inspired from biological neural networks. So it teaches computer to process data in a way that is inspired by human brain. So deep learning models can recognize complex patterns in pictures, text, sounds, and other data to produce accurate insights and predictions. So based upon this detail, we can say that in deep learning, machine learning models are trained just like human brain. So in deep learning, we feed our data to artificial neural network for training. And a neural network has layers, and each layer contains neurons. And using these neurons, pattern is extracted from the data and our model is trained. So as machine learning is all about pattern finding, so in deep learning we extract that pattern using artificial neural networks. And now let's see what is a neural network and how we are going to use it. So you can see this picture on screen, and it is representing a simple structure of neural network. So you can see these circles and these lines joining them. So here each circle is representing a neuron, and a neuron is a basic unit of a neural network, and it can receive one or more inputs, but it will gonna generate a single output value. So there you can see this red circle, so it is representing a neuron, and it will gonna take two values as input, which will gonna come from these two neurons, and then it will gonna generate or calculate a single value which will be the output, and that output will be passed to the next neurons. So the output of this neuron will be passed to this neuron and this one. But the output value generated here will be same for this neuron and also for this neuron. So that's why we say that a neuron receives multiple input and generates single output. So inside a neural network, the first important thing is this neuron, and the second thing is the layer. So as we have said that inside a neural network there are layers, and inside those layers there are neurons. So in this very simple neural network there are three types of layers, and the first type is called input layer, and it is represented with this blue circles. And as the name suggests, at this input layer, we are going to pass input data to our model for training. So let's say we want to train a machine learning model to predict gender of a person based upon his height and weight. So in that case, we are going to pass the height and weight of person to our neural network at the input layer. So this is the first type of layer inside a neural network. And after that, the second type of layer is called hidden layer, and it is represented here with red circles. So the layer after the input layer is called hidden layer, and the pattern from data is extracted here. So as I have repeated multiple times that machine learning is all about pattern finding. So in deep learning, our ultimate goal is to find pattern in the data on which our model is being trained. So the pattern from the data is being extracted at the hidden layer. And right now in this hidden layer there are 3 neurons, but it can have any number of neurons. And similarly, as it's a very simple neural network structure, so it contains a single hidden layer. But there can be multiple hidden layers inside a single neural network. Like here, after this hidden layer, there can be one more hidden layer, and the neurons of this hidden layer will be connected to the neurons of that hidden layer, and so on. So inside a neural network, the pattern is extracted at the hidden layer, and there can be multiple hidden layers inside a single neural network. And after hidden layer, the third type of layer is called output layer. And as the name suggests, the output from the model is being generated here. So as we are predicting the gender of a person based upon his height and weight. So after passing the height and weight of person here at the input layer, we will get the prediction at the output layer. So here, if the value for this male neuron will be greater, then our prediction will be male. And if the value for this female neuron will be greater, then our prediction will be female. So these are 3 types of layers inside a neural network. And at this point, there will be a lot of questions in your mind, and hopefully they will be answered till the end of this lecture. So now in this example, we are predicting the gender of a person based upon his height and weight. So here our prediction will be either male or female. So it's a classification problem, and this neural network is representing the structure for a classification problem. And in case of regression, our neural network will gonna look like this. So let's say we are training a model to predict price of house based upon the area and the number of rooms. So in that case, our output is a continuous value, so it will be a regression problem. And the neural network for that regression problem will gonna look like this. And here at the output layer, we got a single neuron because our output is not fixed and it can be any value. So whatever value generated here will be considered the predicted value of house price. So now let's understand the working of neural network with the help of an example. So let's say we want to train a model to predict price of house given its area and the number of rooms. So to do that, we have this dataset. So there you can see in this dataset we got the area and the number of rooms, and these are our features. And after that we got the house price, and that is our output or our label. And now to train our deep learning or neural network model on this particular dataset, we are going to pass each row of our dataset to our neural network. So for the first row of our dataset, the house area is 1250 and the number of rooms are 4. And the actual price of that house is 50,000. So now we are going to pass the area and the number of rooms at the input layer. So we are going to pass 1250 for the area and 4 for number of rooms. And after passing the data here at the input layer, the next step is calculating the values of neurons in the next layer. So let's name these neurons as Z1, Z2 and Z3. And now we need to find the values of neurons in the hidden layer. And to calculate these values, we are going to use the value of neurons which are connected with them and the weights joining them. So as I told you earlier that the lines joining these neurons are called weights. So now we have assigned random values to these weights. And to calculate the value of neuron in the hidden layer, we are going to use the value of neuron in the input layer and this weight. So firstly, we are going to calculate the value of z1 and it will be calculated using this formula. So we are going to take the neuron which is connected with this z1. So firstly, we are going to take the value of area and then we are going to multiply it with the weight joining these two neurons. So you can see the weight value is 0.1 for this particular line. So you are going to multiply this 1250 with this 0.1 and there you can see we are doing it. And after that you are going to see if any other neuron is connected with this z1. So we can see this rooms is also connected. So we are going to take the value of room and multiply it with this weight 0.2. So there you can see we are doing this as well. And after that we are doing the calculations and finding the value 125.8. So that will be the value for this z1. And using the same formula we are going to calculate the value for z2 and z3 as well. So you can see for z2 we took the value of area and multiplied it with 0.4 and then we multiplied this 4 with 0.1 and we got the value 500.4 and then we did the same for z3. So to calculate a value of neuron we are going to use the value of neurons in the previous layer and the weights joining them. And now after finding these values for z1, z2 and z3, the next step is finding the value for this green neuron or the neuron of our output layer. So let's name this neuron y1. And now to calculate the value for this y1 we are going to use the same procedure. So we are going to take the value of neuron connected with this y1 and multiply it with the weight connecting them. So firstly we are going to multiply this 125.8 with this 0.3 and then we are going to take the value of z2 and multiply it with 0.4 and then this z3 and multiply it with 0.5 and after calculation we will get the value for this y1. So the value for this y1 is 364 and this is actually the prediction for house price. And as we also know the actual price of that house and it is $50,000. So this predicted value is nowhere close to the actual price. And the reason is right now we have started to train our model. And our model or algorithm knows nothing about the pattern which is there in the dataset. But when our model training will gonna complete, then our model will gonna know or it has extracted the pattern from the dataset and we are going to get correct predictions there. And the reason for this thing is right now we have assigned random values to these weights. But now after passing input data to our neural network and getting the predicted value for house price, we are going to compare that price with the actual price of that house. And after that we are going to update these weights. So now once the weights will be updated, then the next time when you are going to pass the same values to this neural network, you are going to get an accurate prediction here as compared to our previous prediction. But for now, we have passed input data to our neural network at the input layer and we have calculated the value of neuron at the output layer. And this process is called feed forwarding. So feed forwarding is the process of passing all your training data to neural network at the input layer and getting the value of neuron at the output layer. And after getting this predicted value, we are going to update these weights. And the process of updating these weights is called backpropagation. So as we are learning about supervised machine learning, so we also know the actual price for that house. So now after comparing that actual value with this predicted value, we are going to update all of these weights. And this process of updating weights is called backpropagation. And these weights will be updated using a formula which will gonna take both this predicted value of house price and the actual value of house price. And then after doing the calculation, the formula will gonna update these weights. And the process of updating these weights is called backpropagation or learning. And we call it learning because now we are changing the weights based upon the pattern inside our dataset. And later, using these weights, we are going to make our prediction. So the process of updating these weights can be called as learning as well. And once we are going to pass all training data to our neural network, and then based upon the predicted and actual value, we are going to update these weights. We are going to say that we have completed an epoch. So an epoch is actually the process of passing input data to neural network and then updating weights based upon actual and predicted results. Or you can also say that one cycle of feed forwarding and back propagation is called an epoch. And during training our model, we set this epoch parameter, and we usually set a larger value for this epoch, like you can say 100. So when we will set this epoch to 100, then it means that for training our model, we are going to pass all training data to our neural network 100 times, and then we are going to update these weights 100 times. So during this process, the value for these weights will be changed during each epoch, and at the end of those 100 epochs, our model will be trained. So after passing whole dataset to neural network multiple times, and then by updating the weights, we will get our trained model. And using this model, we can predict price of house in future. And in actual, our trained model contains specific value for weights of neurons, and using these weights, predictions are done. So when we say that we have trained our model using deep learning or neural network, then in actual we mean that we have found the correct values for these weights, and we have found these values by passing input data to neural network, and after that updating the weights by comparing the predicted and actual value. So now after training our model, we can say our neural network will gonna look like this. So here we will get the values for these weights using which we are going to make the prediction. So now after training the model, the next step is testing that model. So for testing the model, we are going to pass inputs at the input layer. But this time we have not passed these inputs during training. Like somebody told me that his house area is 1550 and the number of rooms are 3. And now he want to get the predicted or estimate for his house price. So we are going to pass his area and the number of rooms here, and then using those formulas, the values for Z1, Z2 and Z3 will be calculated. And after that, applying the same formula but using these new weights, we are going to calculate the value for Y1, and that will be the predicted value of this house price. So that is how a deep learning model is trained using neural network. Or that's how a simple neural network will gonna look like. That it consists of neurons, and these neurons are connected with each other. And for training our model, we are passing all the training data at the input layer, and then the value of neurons in the output layer is calculated. And after that, we are comparing that predicted value with the actual value and updating these weights. And this process is repeated again and again until correct values are set for these weights or our model is trained. Hello guys, Hamza here. I just want to let you know that this video is just the first part of my complete Train Machine Learning Models and Build Mobile Applications course. The complete course is around 20 hours long, and it includes training machine learning and deep learning models and building mobile applications in 3 different app development frameworks like Flutter, native Android with Kotlin, and native iOS with Swift. The complete course includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. Apart from that, you will get a certificate upon completion which you can add to your resume, and the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below, and we are offering a discount to first 100 students. And now let's continue to the next lecture. Welcome to this lecture. In this lecture, we are going to learn about some basic concepts which we are going to use throughout this course. So let's start. So firstly, we have learned about machine learning, that machine learning is all about finding pattern in data using algorithm. And then we have learned about its two main types, which are supervised machine learning and unsupervised machine learning. So in supervised machine learning, we use label data for training our model. So it means that the dataset on which we are training our model contains both input and output, and our algorithm find pattern in that dataset. And then in unsupervised machine learning, we use unlabeled data for training our model. So it means that the dataset which we are using contain only the input values, and then we use algorithm to find pattern in that data. And after that, we have learned about deep learning and its working. So it is a subfield of machine learning where we use artificial neural network for training our model. And in deep learning, we have learned about few important concepts, and the first one is feed forwarding. So feed forwarding is the process of passing input data to our neural network at the input layer. And after that, we are calculating the values of neurons of hidden layer. And then using these values, we are calculating the value of neuron at the output layer. And this whole process is called feed forwarding. So the process starts from input layer and ends at output layer. And after feed forwarding, we have learned about backpropagation. So after calculating the values of neurons at the output layer, we are comparing this predicted value with the actual value. And then we are updating the weights of neural network, and this process of updating weights is called backpropagation. So the process starts from output layer and proceeds towards the input layer. And after backpropagation, the next important thing is called learning rate. So learning rate is a float value used to control how much weights will be updated during backpropagation. So as during backpropagation we are updating the weights, so there we are using this float value, and its role is to control the amount that how much those weights will be updated. So during our model training process, you are also going to set the value for this learning rate. And after this learning rate, the next thing is the loss function. So loss function is used to measure difference between predicted and actual results during model training. And it is used to monitor error of neural network during model training. So as I told you earlier that when we are passing input data at the input layer and calculating the value of neuron at the output layer, then there we are comparing that predicted value with the actual value. So there, to calculate difference between the predicted and actual value, we use this loss function. And it is also called error of neural network because it is indicating the difference between actual and predicted results. And during backpropagations, we are updating the weights in such a way that the value of this loss function will gonna reduce for the next epoch. And after this loss function, the next thing is overfitting. So if we train our machine learning model and our trained model perform well on the training data, but its performance is not good on the testing data, then this problem is called overfitting. And it is because our model starts remembering data instead of finding pattern in that data. So overfitting is a problem which we can have with our trained model. And in this problem, after training the model, our model will not gonna perform well on the data which is new for our model. And to solve this problem, we use a technique that is called dropout. So in dropout, certain neurons are ignored during model training. And by ignoring, we mean that the value of few neurons are not considered during certain epoch of model training. So to tackle that overfitting problem, we use this technique, and in this technique, for certain epoch of our neural network model training, we will ignore the value of some random neuron. And by that way, we can avoid overfitting. Welcome to this lecture. In this lecture, we are going to look at a platform called Google Colab. So as inside this course, you will learn to train machine learning models for mobile applications. And for training our machine learning models, we are going to use Python programming language. So we need a tool or an IDE where we can run the Python code. So instead of installing any software in your system, we are going to use a very useful tool provided by Google, and with the help of this tool we can run Python code inside our browser. And we don't need to have a powerful system to train advanced machine learning models. So the tool which we are going to use is called Google Colab. So to open it, you need to open your browser and go to Google. And there you can type Google Colab and press enter. And now here you need to click on this link research.google.com Colaboratory. So click on it and the home page for Colab will be opened. So there you can see this page is open. So as I am already using Colab, so I can see this dialog. But if I will click cancel, then you will see this page. So this is the page which you will get if you are using it for the first time. And here at the top right corner, you need to attach your Google account with this platform. Otherwise you won't be able to use it. So I currently logged in using my email address. So that is the basic interface of this Google Colab, and here you can run powerful Python code and use all the powerful Python libraries. So here when you will scroll down, you will see the introduction. So Colab or Colaboratory allows you to write and execute Python code in your browser with zero configuration required. Similarly, it provides you the access to the GPUs free of charge, and it also provides you an easy method to share your code. So these are very few advantages of Google Colab, and you will get to know about its benefits once we will proceed in this course. So for now, let's look at some basic operations which we can perform inside this Google Colab. So as we are using it for running our Python code, so here inside this Colab, if you want to run a Python code, you need to create a code cell. So a code cell is similar to this one. So there you can see in this cell, we are declaring a variable with the name seconds in a day. And then we are assigning this value to this variable. And after that, we are printing the value of this variable. So this is a very simple Python code, and we will learn about this syntax inside our upcoming lectures. But for now, you can see these two lines here, and these are present inside a code cell. So if you want to execute this code, you can simply click on this run button, and the code present inside this cell will be executed. So I will click on it. So here for the first time, it will gonna take few seconds to allocate resources to your notebook file. And once done, you will be able to see the RAM and the disk associated with this Colab. And here the execution of this cell is completed and we got this output. Similarly, here you can add more code cells if you want to. Like if I will click on this code plus button, you will see a new cell is added. And here you can write any other Python code. Like I can write a is equal to 5 and then I can print the value of this a. So now let's run it. And there you can see we got the output is equal to 5 here. Similarly, you can add this code cell anywhere inside this notebook file. And after that, apart from these code cells, you can add one more type of cell, which is a text cell. So there you can see, apart from this code cell in this file, we also got these comments. So when you will double click on them, you can see these are also editable, and these are basically the text cells. So you can also add these text cells by clicking on this plus text icon, and a text cell will be added. So you can add as many code cells and as many text cells and easily arrange your code. So that is a basic introduction of Google Colab, that inside it you can write your Python code and execute it without installing any software inside your computer. And now let's see some basic operations which we can perform inside Google Colab. So just like any other IDE or any other code editor, here you can create multiple code files. and a file in Google Colab is called a notebook. So here when you will click on this file button, you will see this option for new notebook, open notebook and upload notebook. Similarly, you can also download or save your notebooks here. So the standard format for storing this notebook or the code file is IPYNB, which is for Python notebook. But you can also save it as a Python file with the extension py. So here let's create a new notebook so that we can see it, and then we are going to download it and then we are going to open it. So there you can see our new notebook file is created, and here we are going to write a simple code like we can set a is equal to 10 and then we can print the value of a. And now let's run this cell. So there you can see the cell is executed and we got the output is equal to 10. So now you can change the name of this notebook by simply clicking here. So I can name it starter. And after that, if you want to download it, then you can click on this file and then go to download and download it as a notebook file. So there you can see the file is downloaded. And now if you want to open this downloaded file, then let's just firstly close it, and here inside our original notebook click on file and then this upload notebook, and then you can browse to the location where you downloaded it. So I got it here, so I will select it. So there you can see our notebook file is opened. So these are some basic operations which we can perform inside Google Colab. And inside upcoming lectures, we are going to use this Google Colab for training our advanced machine learning models for mobile applications. Welcome to this lecture. In this lecture, we will start learning about the basic syntax of Python programming language. So as inside this course, we are going to train machine learning models, and then we are going to use these models inside our mobile applications. So for training these models, we are going to use the Python language. And inside these few lectures, we are going to cover some very basic things which you need to know so that you can easily understand the process of model training. So here, in order to learn about Python, you need to open the course resources, and there you need to go inside this Python folder, and there you will find this notebook file and this Python file. So you need to open this notebook file inside Google Colab, and you can also check this lecture resources and you will find these files. So here on Google Colab, you need to click on this file button and then this upload notebook. And then here you can simply drag the file or select it. So I will simply drag it and put it here. So there you can see our notebook file is opened. And there you can firstly see the introduction of this language. So Python is interpreted programming language which is being used by developers worldwide to develop various things like websites, machine learning algorithms, and also simplifying and automating day-to-day tasks. Basically, Python is a language that can be used for developing anything and everything you want. So it is very powerful programming language, and it is good to have some basic knowledge of this language. So we are going to start by looking at the variables and data types in Python. So Python variables do not need any explicit declaration to reserve memory space. So it means that in Python, while declaring variables, we don't need to specify the data type of the variable. But based upon the value which we are storing inside the variable, the memory is allocated to this variable. So for example, if we are creating this v1 is equal to 5, so as it is an integer value, so in Python this v1 will be assigned the data type integer. So you don't need to explicitly specify the data type here, but the data type will be assigned to the variables based upon the value stored inside them. And here, in order to test this, you can simply run this cell and you will be able to see integer here. So there you can see it is already showing this output, but when this cell is executed again, you will see the integer here again. So there you can see that. So now inside this notebook, there are outputs printed for all the code cells. But in order to learn effectively, you can hide these outputs by clicking on this edit and then selecting this clear all outputs, and it will gonna remove all outputs, and now we will see the outputs as we are going to run the cells. So let's run this cell again and you will see integer here. So there you can see that. Similarly, if we create this v2 variable and set the value 5.0 and now we print the type of this variable using this type function, you will see the type will be float because now we stored the float value inside this variable. So there you can see that. And now let's create this v3 variable and store the string inside it. And now when we print the value, you will see the output equal to string. So there you can see that. So that is one basic thing about Python variable, that we don't need to manually specify the data type here. And now let's look at Python data types. So Python has 5 standard data types, and these are numbers, string, list, tuple and dictionary. And we will start with Python numbers. If you want to become a mobile machine learning expert, then subscribe to this channel and get 92% off on our mobile machine learning courses. Links are given in the description. And we will start with Python numbers. So in Python, in order to create number variables, you can simply write the name of the variable and then assign the value to it. Like here we are creating this v1 variable and assigning the value 1, and then we are creating this v2 variable and assigning 100 here, and then we are printing this v2 as well. So let's run this cell and you will see the output equal to 100. And after that, if you want to free the space of this v1 or v2 variable, then you can simply write this del keyword and the name of the variable which you want to delete. And now this variable will be deleted from the memory. So here let's try it. So there you can see now this variable is deleted. So if I add a code cell here and type v1, which is now deleted, and then I will run it, there you can see we got an error that v1 is not defined, and the reason is we have just deleted v1 here. Similarly, if we type v2 and print the value, now we will get the result because v2 is declared here and we did not delete it yet. So there you can see that. And now let's explore Python numbers further. So Python supports 4 different numerical types, and these are integer, long, float and complex. And here this integer, long and float are similar to any other programming language, but this complex is a data type which we usually find in Python. So in Python, apart from these integer, long and float, you can also create complex variables. And in complex variable, there are 2 parts. One is a real part and one is an imaginary part. Like if you want to declare a complex number, then you can do it just like that. So v3 is equal to 1 plus 3.14j. So here this 1 is the real part of this complex number and this 3.14 is the imaginary part. And you cannot declare this type of variable in most of the programming language. So here after creating this variable, we are printing its type. So let's run it. So there you can see the type of this variable is complex. And now let's print the value of this variable, so v3, and there you can see we got this value here. So that is a basic introduction of Python numbers, and it is only first of 5 data types which Python have. So now after looking at Python numbers, the next data type is Python string. So in order to declare string in Pythons, you can use single quotations. Like here we are creating this str variable and then we are specifying the value inside single quotations. So this string will be created. And now if you want to print the value of this string, you can simply use this print function and specify the variable name. And after that, if we are going to run this cell, you will be able to see the output here. So there you can see we got this value hello world. But apart from that, we also got these values here. So here we have performed few operations on Python strings and we got the output here. So let's cover them one by one. So there you can see after printing the value of this string, we are showing the value which is present at the index 0. So in Python, we can treat string as an array of characters. And as inside an array, we can get the value by specifying the index. So here you can do the same. So we specified the index 0 and we got the value h here because h is present at the index 0. And then if you want to get the substring of this string or you want to get a portion of this string, then you can get it with the help of this slice notation. So you need to specify the name of the variables and then inside these square brackets you need to specify the start index and the end index. So for example, if we specify 2 to 5, now it means that we want to get the value of this string starting from the index 2 till the index 4. So here the ending index is not inclusive. So if you specify 2 till 5, then it will gonna start from index 2 till the index 4. So there you can see when we printed this value, we got this result LLO. And this notation in Python string is called slice notation. And similarly, if you want to print this string starting from the index 2 till the end, then you can leave this value empty and it will gonna print the string till end. So there you can see we got this output here, or our string is printed till the end. And now if you multiply your string variable with any integer value, you will see this output. So basically we multiplied string with 2 and it actually replicated that string. And if you specify 5 here, then you will be able to see this hello word 5 times. And if you want to concatenate the string, then you can simply use this plus operator. So there you can see we got the value hello world test. So these are some basic operations which you can perform on Python strings. So after Python strings, the next data type is Python list, and it is most important data type in Python. So lists are most versatile of Python compound data type. A list contains items separated by commas and enclosed within square brackets. So in order to create a list in Python, you need to name the list and then inside these square brackets you can specify the items of the list. And one amazing thing in Python is that a list can contain items of different data types. Like here we created this list and the first value is an integer. And the second value here is a string, and the third value is again an integer, and the fourth value is a float value. And we put all inside a single list. So let's run this cell so that we can see the creation of this list. And now if we want to print the first value of this list, you can simply specify the index and you will get the value 10. And if you want to get the type of this first element, then you can put this thing inside this type function and run this cell and you will see the type integer here. So there you can see that. And if you want to see the type of second variable, which is a string, then you can do this. And there you can see we got the output equal to string. And if you want to print a range of values inside this list just like strings, then you can use this slice notation. So here we are specifying that print the value of this list starting from index 1 till index 2. So when we will run it, you will see the output. So there you can see the output is hello and 20. So it printed this list starting from the first element till the second element. And in Python list, you can also simply reassign an item, like if you want to change this 2 with another list which contain 1, 2, then you can simply do that. So let's run it. And now let's print the value at index 2. And now you can see the index 2 contain this another list which contain 1, 2. And when you will print this list, you will be able to see this output. So there you can see now inside our Python list at the index 2 we got another list which contain the values 1, 2. So inside Python list we can have anything. So there you have seen that we can have a variable of type multiple data types and also have a list inside a Python list. And now let's look at few methods of Python list. And the first and the most used method is append. So append is used to add single item at the end of list. So if inside our list you want to add a value 1, then you can do this and print the value. And you will see after this 30 we will get this 1. So there you can see that. And if you want to do this thing but without this append function, then you can also do it like this. So you can use this plus operator and then specify the values which you want to add. Like here, after doing it, when we will run it, you can see 2 and 3 are appended inside our list. And by using this plus operator to append our list is called in place operation. And it is called in place because it is done immediately in the memory. So now let's cover some more methods of Python list. Like here we created this list and we added these values inside. So let's run this cell and now our list will be created. So now if you want to get the count of a specific value which is present inside your list, you can easily do that with the help of this list.count function. Like if you want to know the count of 2, like how many times 2 occurred inside this list, then you can easily do that like this. So list.count and specify the value, and now it will gonna check that the 2 is present 2 times, so we will get the output 2 here. So let's run it. So there you can see we got the output is equal to 2. And if you want to get the count of this 3, you can simply change the value here and run it again. And now you can see we got 1 here. So you can get count of any value which is present inside this list. Similarly, if you want to get the index of any value, you can get it with the help of index function. And the index method tells you the index of first occurrence of an element. Like here, if we will use this list.index and specify 2, then it will gonna show us the index of 2, but it will gonna show the index of first 2 which appears in this list. So let's run it and we should get the output equal to 1 because 2 is present at the index 1. So there you can see that. So now after this index, we got this insert function. So insert function is used to add a value inside a list at a particular index. So there you have seen this append function. So this function will gonna add the value at the end of the list. But if you want to add an element at a specific index, you can use this insert function. So here we are using this list.insert, and then we are firstly specifying the index where we want to add the value, and then we are specifying the value which we want to add. So let's run this cell, and there you can see now at index 3 we got the value 111. And earlier inside our list we got 6 elements, but now we got 7. So it will gonna insert the value at the index and move the rest of the values. Similarly, if you want to remove a particular value, you can use this list.remove function, and then you need to specify the value which you want to remove. So let's remove this 111, and there you can see the value is removed. And now the next useful function is sorting a list. So sort method is used to sort element of a list. So for now in this list you can see our list is not sorted. But if you want to sort it, you can simply use this list.sort and then print the value. So there you can see our list is now sorted in the ascending order. But if you want to reverse this list, like you want to move the first element to the last and the last to the first and so on, then you can use this list.reverse function. So when we will do that, you will see the output that now our list is totally reversed. So that is a very basic introduction of Python list. And now the next data type is Python tuples. So a tuple is another sequence data type that is similar to a list. So a tuple consists of number of values separated by commas. But unlike list, tuples are enclosed within parentheses. So the main difference between list and tuple are, list is enclosed within square brackets and their size and element can be changed, while tuples are enclosed within parentheses and they cannot be updated. So tuples can be thought of as read-only list. So based upon this description, we can infer that tuples are similar to the list, but the only difference is after creating a tuple, we cannot make any change inside it. So in Python, for creating a tuple, you will firstly name it, and then within these parentheses, you will specify the element of tuple. And there you can see, just like list, we are specifying elements of different data types here. So now let's run this cell and our tuple will be created. So there you can see that. And now if you want to get a particular element of a tuple, then you can specify the index and get the element. Like here we are getting the first element, so we got 10 here. And similarly, if you will specify 1, then you will get this hello here. And now if you will try to change the tuple, you will get an error because tuples cannot be changed. And after tuples, the next data type is Python dictionary. So dictionaries works on the concept of key value pair. So for each value you have a unique key associated to it. So in Python, dictionaries are created in the form of key value pair. So it means that for each value which you want to add inside a dictionary, you need to specify a unique key for it. Like here we are creating this dictionary, and for creating it we will use these curly braces, and then inside it for each element you will define a unique key. So here for the first one we are specifying the key k1, and then we are specifying the value equal to 1. And after that for the second element of the dictionary we are defining another key, and then we are specifying the value. And then you can see we are adding another element with the key k3, and this time we are defining a float value. So that's how you can create a dictionary in Python, that you need to specify a unique key for each element which you want to add inside that dictionary. And then while accessing that element you are going to use that key to get the value. Like here, let's firstly run this cell to create this dictionary. And now if we want to get the second element, which is a text home, then we need to specify the key for it. So here we will specify the key k2 and then print it. And there you can see we got the value home. And similarly, if we will specify k3 here and run the cell again, then you can see we got the value 30.2, and it is the value specified with the key k3. So that's how you can create dictionary in Python. And now the next thing is conditional statements and loops in Python. So firstly, let's cover the conditional statements. So just like any other programming language, the basic conditional statement in Python is if. And if you want to use it, then you will use the if keyword, and after that you will specify your condition. And here while specifying the condition you don't need to use parentheses, but after the condition use this colon operator, and then on the next line specify the body of if statement. So here we are creating two variables v1 and v2, and then we are checking that if v1 is greater than v2, then print v1 is greater. And after that we are adding an else if block. So in Python for else if we are using the keyword elif, and it is equivalent to else if block, and then you will specify the condition and then the colon. So here we are checking that else if v2 is greater than v1, then print v2 is greater. And then finally we are adding an else block and then the work which we want to do. So in the else block we are saying that v1 is equal to v2 because both of them are equal unless one of the above statement will be true. So now let's run this cell. And there you can see we got the output v1 is equal to v2, and the reason is the value for both variable is equal. So now let's change the v2 to like 18 and run the code again. And there you can see this time this block is executed because v2 is now greater than v1. So we printed the message v2 is greater. So that's how you can use if-else statements in Python. And after that let's cover the Python loops. So the first loop which we are going to use is a while loop. So in Python for using the while loop you will use this while keyword, and then inside parentheses you will specify the condition. So here we created a variable with the name count and we set it to 5. And now we added the condition that while count is less than equal to 5, print the value of count and increment the count. So now let's run it. And there you can see it printed 1, 2, 3, 4 and 5. So those were the values of this count variable inside this loop. So until the count is less than equal to 5, we printed its value. So there you can see that. And once the value of count was greater than 5, then we came out of this loop. So that's how you can use while loop in Python. And after that the next loop is a for loop. So in Python the for loop is mostly used with Python list. Like there you can see we are creating a Python list with these elements. And then we are iterating this list with the help of a for loop. So for v in list, print the value of v, and it will gonna print each element of this list one by one. So let's run this cell. And there you can see it printed the value 1, 2, 3, 4, and finally it printed the name Hamza here. So that's how you can iterate list in Python using a for loop. And after that you can see we are using for loop with a string. So as I told you earlier that in Python, string is actually a list of characters. So just like any other list, we can iterate it using a for loop. So for v in Python, and then we are printing v, and it will gonna print each character of this string one by one. So let's run this cell. And there you can see it printed python. So basically it treated this string just like a list and printed its elements one by one. And now after covering the conditional statements and loops in Python, the next thing is taking user input. So there can be the scenarios where we need to take some input from the user. So in Python, to do that, we are going to use this input function. And then inside the parentheses, you will specify the message which you want to show. And once user will gonna enter the value, that value will be stored inside this s1 variable. And after that, we are printing that variable here. So let's run this cell. And there you can see the box with the message enter your name. So you need to type your name here and then press enter. And after that it printed the value here because here we are printing that value. So that's how you can take user input in Python. So now the next thing is dealing with files in Python. So while training our machine learning model, we can encounter a scenario where we need to deal with files inside Python. Like after training the model, if we want to save it inside a TFLite format or inside any other format, then we need to create that file. And similarly, there can be the scenarios where we need to read the data from file in Python. So it's important to learn that how we can read and write to a file in Python. So here at the bottom of this notebook, we got this opening and closing file section. And there you can see this detail, but you can also see this error. So basically here we have put this comment inside a code cell. So that is by mistake and we should put it inside a text cell. So let's firstly cut the content and then we are going to delete this cell. And after that we can add a text cell here and paste the content inside it. So now let's read it. So while opening file, you need to specify the file name and the mode in which you want to open the file. So the mode can be R for reading, W for writing, WB for writing in a binary format, RB for reading in a binary format, and A for appending an existing file. So these are few modes in which you can open files. So now let's start by opening and writing to a file. So there you can see in this cell we are using this open function to open this file. So firstly you need to specify the name of the file which you want to open and then the mode in which you want to open it. So as we want to write to a file, so we specified the mode to W and the file name is a.txt. So now this open function will try to open this a.txt file, and if this file is not existing, then it will gonna create it. But where it will gonna create the file or from where it will gonna try to open the file? And the answer is this files pane. So you can see this files icon here, so just click on it and you will see this pane. So here you will see all the files associated with this code notebook. So here when we will run it, you will see a new file will be created because there is no a.txt file here. So there you can see the cell is executed. So now when we will refresh it, you will see this file a.txt. And now to this file you can write anything which you want. But we will do that in a minute. But now let's check few operators of the file. So firstly, if you want to check that if a file is open or closed, then you can use this f.closed property. So now when you will run it, you will see an output. So there you can see I got false here, which means that our file is not closed yet and it is open. And there you can see this error. It is maybe because of this space, so I will remove it and the error is gone. And after that, if you want to close a file, then you can use this f.close function and it will gonna close our file. And then if you will run this f.close, you will get true here, because now we have closed this a.txt. And after that, let's start reading and writing to a file. So here we are firstly opening this intro.txt file in a writing mode. And then we are creating a string variable and putting the text Python is fun inside. And then we are using this file.write function and specifying the value which we want to write. And after that we are closing the file. So let's run this cell and our intro.txt will be created. So there you can see that. So now if you want to download this file, you can simply click on this download button and this file will be downloaded. And when you will open it, you will see this text Python is fun here. But if you want to read the content of this intro.txt inside our Python code, then you can open it inside a reading mode and then you can use this f.read function. So this function will gonna read the content of this file till the index 10, or it will gonna read first 10 characters from the file. And we are assigning the result to this str2 variable and then printing the value of this variable. So let's run this cell. And you can see we got the output Python is and then this space. And the reason is we only specified 10 here. But if we do not specify any index and run it again, now you will see all the content of this file, so Python is fun. So that's how you can write a content to a file in Python, and that's how you can read a content from a file in Python. Hello guys, Hamza here. I just want to let you know that this video is just the first part of my complete Train Machine Learning Models and Build Mobile Applications course. The complete course is around 20 hours long and it includes training machine learning and deep learning models and building mobile applications in 3 different app development frameworks like Flutter, native Android with Kotlin, and native iOS with Swift. The complete course includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. Apart from that, you will get a certificate upon completion which you can add to your resume, and the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below, and we are offering a discount to first 100 students. And now let's continue to the next lecture. Welcome to this lecture. In this lecture, we will start learning about few data science libraries, and these libraries will help us during our model training process. So let's start. So the first library of this series is called NumPy. And before learning about this library, you need to open this NumPy notebook file inside Google Colab. So you can check the resources of this lecture, or you can go to the course resources, and there in the data science libraries folder, you need to go inside NumPy folder, and there you will find this notebook file. So you just need to open this file inside Google Colab, and once you will do that, you will be able to see all of this code. So now let's start learning about this library. So NumPy is a library for Python programming language, and it provides support for large multidimensional arrays and matrices. Apart from that, it provides a large collection of high-level mathematical functions to operate on these arrays. So based upon this description, we can say that NumPy is a library using which we can create multidimensional arrays, and we can apply a lot of functions or operations on these arrays. And in practice, we use this library in Python for creating our dummy datasets and also applying different operations on our datasets. So now let's start learning about this library. So to use this library, firstly you need to import it. And for importing a library in Python, you need to use this import statement and then the name of the library. And after that, you will assign an alias to the library. So now we are importing NumPy as NP. And wherever we want to use this library, we are going to use this NP keyword. Similarly, you can use any word here which you like. So let's run this cell so that our library will be imported. And as it's the first code cell of this notebook, so it will gonna take some time. So there you can see it is executed successfully, which means that our library is imported. So after importing this library, let's create an array using this library. So to create an array, we can use this np.array function, and then you need to specify the elements of the array, and you will specify them inside these curly braces, and then we are printing this array. So let's run this cell. And there you can see we got this array here, and as you can see the output is there for all the cells, so you can hide it just like our Python notebook. So here you can go to the edit and then click on this clear all outputs, and now all the outputs will be hidden. And now we can learn more effectively. So let's run the cell again so that we can see this array, and after that you can see in the next cell we are printing some information about this NumPy array. So let's run it and then we will see this detail. So firstly we are printing the array just like we did above. So there you can see we are getting the values of the array, which are 1 and 2. And after that we are printing the type of this array. So there you can see the type is numpy.ndArray. So here this ndArray is actually specifying n-dimensional array. And then we are printing the shape of this array. So the shape gives us this output. So as it's a single dimensional array with 2 elements, so we are getting this 2 here. And then we are printing the size, and we are getting 2 here because there are 2 elements present in that array. And now let's create a 2-dimensional array in NumPy, and to do that we are using this np.array. And now to define a multi-dimensional array we are using 2 square brackets here. So here firstly you can see we are specifying the first row and then this second row here. So this will be an array of size 2 into 2, which means that 2 rows and 2 columns. So let's run it and our array will be created. And now let's print the properties. So there you can see firstly we printed the array and we got this data. So the first row contain element 1 and 2, and the second row contain the element 3 and 4. And after that we are printing the type of this array, and the type of this array is again numpy.ndArray. And then we are printing the shape. So this time the shape consists of 2 rows and 2 columns. And then the size, so as there are total 4 elements in this array, so the size is 4. Similarly, if you want to add another row here in this array, then you can add a square brackets here and add the elements like 5, 6, and then we are going to run it. And after that let's print the properties. And there you can see now there are 3 rows inside our array and 2 columns. And if you want to add one more column, then you need to specify the third element inside each row. And let's print the properties. And there you can see we got 3 rows and 3 columns inside our array. So that's how you can create an n-dimensional array inside NumPy. And now while creating arrays, if you want to specify the data type of the elements, then you can also manually do that. So there you can see now to specify the data type, we will add a parameter dtype inside this array function. And there we are specifying np.float32. So basically we are specifying that create an array where each element will be of type float32, and then we are printing the type of first element. So let's run it. And there you can see the type of first element is float32, and that will be the type of each element of this array. So while creating these arrays, you can also specify the data type which you want to assign to the elements. And after creating these arrays, let's look at some built-in functions. So here in NumPy, if you want to create an array filled with 0, then you can use this mp.zeros. Then inside these parentheses, you need to specify the shape of the array which you want to create. And after that, we are printing the array. So now here we are creating a 3-dimensional array. So let's run it. And there you can see the array, and each element of this array is filled with 0. Similarly, if you want to fill them with 1, then you can use this mp.ones function and then specify the shape. So let's run it. And there you can see we got this array where each element contains the value 1. And these functions can be very handy or useful while training our model, because there we may need to create some dummy data sets. So there we can use them. So now let's see how we can create an array with random values. So to do that, we will use this numpy.random.random function, and there you will specify the shape of the array which you want to create. So now let's run it, and you will see a 4 by 4 array will be created, and it is filled with random values. So now let's run it again, and you will notice different values here. So there you can see that. So each time you will run it, you will get a different values because they are being generated randomly. And if you want to fill them with a particular value apart from 0 and 1, then you can use this numpy.full function. And there firstly you will specify the shape and then the value which you want to fill. So let's run it, and you will see a 4 by 4 array will be created with 9 filled at each index. So there you can see that. So that's how you can create arrays in NumPy with a particular value or with random values. And after looking at these built-in functions, the next thing is reshaping an array. So in NumPy, if you want to change the shape of an array, then you can do that with the help of this reshape function. So as we created this array here, and now we are calling this array.reshape function. And here we are specifying the output shape. And here while specifying this shape, you need to make sure that you are specifying a correct shape here. So as our input array contains 4 rows and 4 columns, so there are total 16 values inside this array. So while reshaping it, we need to make sure that our resultant array can also contain 16 elements. So let's run it, and you will see the output array, and there you can see that. So now we change the shape of this array to this particular shape. So that's how you can reshape an array. And after that, if you want to flatten an array, which means that you want to convert a multi-dimensional array into a single dimensional array, then you can do that with the help of flatten function. So here firstly we are creating a 2D array with 2 rows and 4 columns. So let's create and print it. So there you can see this array. And now if you want to convert it into a single dimensional array, then you can do that with the help of this array.flatten function. So there you can see that. So now we have changed the shape of this array into a 1D array. And now after learning about these functions, the next thing is operators in NumPy. So firstly we are going to look at unary operators. So unary operators are such operators which can be applied on single object of NumPy. So there you can see we are creating a NumPy array with these particular values. And after that we are getting the minimum value of this array with the help of this array.min function. And if you want to get the maximum value, then you can use this max function. And if you want to get the sum of the elements, then you can use this sum function. So let's run this cell, and you will see the output. So the minimum value of this array is 1 and the maximum value is 6, and the sum of all the values is 21. And after unary operator, let's look at some binary operators. So binary operators are such operators which are applied on multiple objects of NumPy arrays. So there you can see we are creating 2 NumPy arrays here. So firstly this array which contain 1, 2, and then this array 2 which contain 3, 4. And after that, if you want to add the first element of array 2 into first element of array 1 and the second element of array 2 with the second element of array 1, then you can do that with the help of plus operator. So when we will run this cell, you will see the output. So there you can see the result of this line is 4 and 6. So here we get this 4 by adding this 1 with 3, and we got this second value by adding this 2 with 4. So there you can see the output. And if you want to multiply them element wise, then you can use this multiplication operator. So here while multiplying 1 with 3 we got 3, and while multiplying 2 with 4 we got 8. And similarly, if you want to perform subtraction or division, then you can also do that by specifying the symbol here. And after that, if you want to get the dot products of these two arrays, then you can do that with the help of this array.dot function. and here you are specifying the second array with which you want to get the dot product. So after binary operators, the next thing is matrix multiplication. So if you are familiar with matrices, then you know that there is a specific multiplication which is used while multiplying two matrices. So here in NumPy, the arrays are also considered as matrices. So here if you want to multiply two n-dimensional arrays just like matrices, then you can do that with the help of this numpy.matmul function. So here we created this m1 and m2 which are two-dimensional arrays, and then we are multiplying them just like matrices. So here let's run this cell and you will see this output. So we got this output by multiplying the first array or first matrix with this second matrix, but this multiplication is as per rules of matrix multiplication. And after that, the next thing is sorting an array. So in NumPy, if you want to sort an array, then you can use this np.sort function. So to look at it, firstly run this cell where we are creating a two-dimensional array. So this array contains 4 rows and 3 columns, and it is filled with random values, as you can see that. So now if you want to sort it, then you can use this np.sort function. So here you will specify the array which you want to sort, and after that you need to specify the axis along which you want to sort it. So as it is a two-dimensional array, so it will gonna ask you whether you want to sort it row wise or column wise. So if you want to sort it row wise, then you will specify the x is equal to 1. So here when we will run it, and you will see the output. So now you can see all the rows are sorted. So the first row contain minimum value, and then the value which is bigger than that, and then the value which is maximum. And same will be the case for all the rows. But if you want to sort them column wise, then you can specify the x is equal to 0. So let's run it. And now you can see they are sorted column wise. If you want to become a mobile machine learning expert, then subscribe to this channel and get 92% off on our mobile machine learning courses. Links are given in the description. Welcome to this lecture. In this lecture, we are going to look at the second library of our data science library series, and that library is called Pandas. So let's start. So in order to learn about this library in the course resources, you need to go to the Pandas folder, and this folder is present inside data science libraries. And you will also find this folder in the resources of this lecture. So in this folder, you will find this pandas.notebook file. So open this file inside Google Colab and you will be able to see this code. And now let's start learning about it. So in computer programming, Pandas is a software library written for Python programming language for data manipulation and analysis. So as this definition suggests, Pandas is a library used in Python for working with datasets. So it provides a number of features using which we can perform different operations on our datasets. And these things will be clear once we will cover the working of this library. And in Pandas, there is a specific data type which is called a data frame. So Pandas data frame is a two-dimensional heterogeneous tabular data structure with the label axis. So Pandas data frame can be thought of as a table with rows and columns. So Pandas data frame consists of 3 principal components: the data, rows and columns. So now let's start learning about this library so that these details will be clear for us. So in order to use this library, firstly we need to import it. So we are importing pandas as PD, and we are also importing NumPy library because we are also going to use it. So here let's import this library by running this cell, and it will gonna take some time as it's the first code cell of this notebook. So the resources are being allocated and you can see it here. And there you can see we got the resources here, and this cell is executed as well. And now here, firstly we are creating a Python list, and in this list there are 3 elements, this 10, 100 and 1000. And after that we are converting this Python list into data frame with the help of this pandas.dataframe function. So here we are specifying this Python list and we are getting this data frame, and then we are also printing it. So let's run this cell. And you will see this output. So here we converted this list into a data frame, and once we did that, you can see we got a table here, and in this table there are 3 rows, and the first row contains the value 10, the second row contains 100, and the third row contains 1000. And the reason is we converted our list into a data frame, and as we mentioned here, it is a tabular data structure. So in short, it converted our list into a table, and in this table there are 3 rows and a single column. And for now, these rows and columns are not named with anything, but later we can also change the name of the columns as well, just like any other table. So now after creating this basic data frame, let's create an advanced data frame. So here let's firstly click on this edit and click on this clear all outputs to hide all the outputs. So I clicked on it, and now all the outputs are hidden. And now let's create a data frame from a dictionary. So here firstly we are creating a Python dictionary. So as we learned earlier that in dictionary the elements are specified in the form of key value pair. So the first key is name, and the value is this list which contain different names. And after that, for the second element, the key is age, and the value is this list which contain these values. So now we are creating a Python dictionary here, and then we are converting it into a data frame. So pd.dataFrame, and we are specifying this data here, and then we are also printing this data frame. So let's run this cell. And there you can see the output. So in the output we got this table where there are 2 columns. The first column is name and the second column is age. So it contains all these names and it contains the age. So this data is looking much more better in the form of data frame. And in future we are going to load our data sets for training our machine learning models using this Pandas library. And now after creating a data frame from a list and also from a dictionary, it's time to create a data frame from a CSV file. So CSV stands for comma separated values, and it is a standard format for having large data sets. So now if you want to load a CSV file and convert it into a data frame, then you can do that with the help of pandas.readCSV function. And there you need to specify the mode in which you want to open the file. So there you can see we specify the R mode, which is for reading, and then you need to specify the path of the file. So here we specified this path, but we did not uploaded any file on this Google Colab. But now we are going to do that. So here click on this files pane, because here we can upload our files, and we have learned about it inside our Python section. And after that open the course resources, and in the pandas folder you will find this pandas dataset. So just open it and you will find this nba.csv. So just drag this file and put it here, and now this file will be uploaded in the files pane of our code. So there you can see this file, and now the path of this file will be content/nba.csv. So now let's run it, and our file will be loaded and converted into data frame. And now let's print this data frame. And there you can see the data it contains. So there are 458 rows in this CSV file, and each row contains 9 columns. So as it is the dataset of NBA players, so we got the name of the player, its team name, number, position, age, height, weight, college, and salary. And we have loaded this dataset in the form of data frame with the help of Pandas library. And in future, while training our machine learning models, we are going to load our datasets in the same way. So now after looking at this data frame, let's print the type of this data frame by using this type function. And there you can see the type is data frame. So now after looking at the creation of data frame from different things, it's time to look at different operations which we can perform on datasets with the help of Pandas library. And the first operation which we are going to perform is handling missing values. So what does that mean? So it means that while collecting our dataset, there are chances that few rows of our dataset contain some missing values. Like you can see this row of the dataset. So here we got plot the value for all the columns except this college column. So for college we got NaN, which is representing a missing value. So now if we want to handle all the missing values in a particular way, we can also do that with the help of Pandas. So here we are creating a dictionary and then a data frame from it. So let's run this cell and our data frame will be created, and there you can see that. So in this data frame, for the first score column we got a missing value in the third row, and we got one missing value here and one here. And now if you want to check that which rows contain missing values, then you can use this df.isNull function. So let's run it. And there you can see it is showing you this table, and here wherever there is a missing value it is returning true. Like you can see this true here, here and here. And inside our dataset we got the missing values present at those positions. So now after getting the position of these missing values, if you want to fill them with a particular value, like if we want to fill them with value 10, then we can do that with the help of df.fillNow, and then we are specifying the value which we want to fill. So here it will gonna fill all these three missing values with 10. So let's run it. And there you can see all the values are filled with value 10 here. And now if you want to drop those rows which contain these missing values, then you can use this df.dropNow function, and it will gonna drop the rows which contain missing values. So let's run it. And now our dataset contain only this row where there is no missing value. And as in all other three rows there was missing value for some columns, so it has actually dropped those rows or removed them from our data frame. So that's how you can handle missing values in your dataset with the help of Pandas data frame. And if you want to get the shape of your data frame, then you can use this df.shape and you will get the shape of the data frame. So as our data frame consists of 4 rows and 3 columns, so we got this output here. So that is a basic introduction of Pandas library and how we can use this library for manipulating and analyzing our data. And you have seen this thing in this small notebook file, that here we have loaded our dataset and then we have also manipulated our dataset by handling those missing values. So the first element of first column contain the minimum value and the last element of first column contain the maximum value. And that is the case for all the columns. So that's how you can sort multi-dimensional arrays in NumPy. And that is a basic introduction of NumPy library. And while training our model, you will see we are going to use this library for few operations. Welcome to this lecture. In this lecture, we will look at the third library of our data science series, and that library is called Matplotlib. And by using this library, we are going to visualize our data or plot it in the form of charts and graphs. So Matplotlib is an amazing visualization library in Python for 2D plots of arrays. So now for using this library, firstly you need to open this notebook file inside Google Colab. So you can check the resources of this lecture or course resources. And there in the Matplotlib folder, you will find this matplotlib.notebook file. So you need to open this file inside Google Colab and you will be able to see this code. So now let's start using this library. So Matplotlib is an amazing visualization library in Python for 2D plots of arrays. So as the definition suggests, this library is used to plot your data in the form of graphs or charts so that you can easily visualize your data and analyze it. So now let's start using this library by importing it. So to import the library, we are going to use this matplotlib.pyplot and we are going to import it as plt. So let's run this cell and our library will be imported. So there you can see the cell is executed, which means that our library is imported successfully. So now let's see how we can plot arrays using this library. So here we are creating two Python lists, and there the first list contains the elements 10, 20 and 30, and the second list contains 3, 2, 1. And now if we want to plot these two arrays, then we can use this plt.plot function, and there you will specify the x and y parameters. So the x will be the first array which you want to plot and y will be the second array. So here before running this cell, let's click on edit and click on this clear all outputs function, and it will gonna hide all the outputs. So now let's run this cell so that we can see the plot, and there you can see the output. So in the output we got this graph here, and here we got this line based upon the points present in those arrays. So as the first value of x array is 10 and the first value of y array is 3, so there you can see on the y axis we got this line starting from 3, and on x axis it is starting from 10. And then the second value is 20 and the y is 2. So based upon this point, our point will be at that position, so our line started from here reached here. And then for the third point of x and y, our point was here, so our line reached here. So that's how this plot is being generated based upon these values. Similarly, instead of this line, if you want to plot them with the help of bars, then you can use this plt.bar function, and it will gonna plot it in the form of bars. So let's run this cell, and there you can see the output. So again, as our first point was at this particular position, so the first bar is starting from 10 and reaching 3, and the second bar is starting from 20 and it is reaching 2, and the third bar is starting at 30 and it is reaching 1. And if you want to plot it some other way, like a scatter plot, then you can use this plt.scatter. So let's run it. And there you can see this time we just got the points and we are not getting any line or bar here. So it is indicating the points based upon the data inside our arrays. And these graphs are very useful while working with larger data sets on which we are going to train our model. And after looking at these graphs, the next step is working with images using this library. So if you want to load images inside Python notebook, then you can also do that with the help of this library. So firstly, we are importing it using this matplotlib.image as IM. So we are loading the image module of this library. So let's run this cell. And after that, if you want to load some image which is present in the file section, then you can do that with the help of im.imread function. And there you need to specify the path of the image. And after that, we are using this plt.imshow function, and we are passing this img variable here. So it will gonna print or show our image here. But before that, we need to add the image in the files pane. So in course resources, inside this matplotlib, you will also find this images folder. So just open it, and inside it we got this image.png. So just drag it and put it here, and now this image will be uploaded here. So there you can see that. So now let's run this cell and you will see this image here. So there you can see that. So that's how you can load images inside Python using this library. So when we are loading this image using Matplotlib, the image is being loaded as NumPy array. Like here, if you move the cursor to this img variable, you can see it is actually an ND array with shape 567, 604, 4. So this image is being treated just like a NumPy array. So here, if you want to see the shape of this array, then you can use this img.shape. And there you can see this shape here. And if you want to view the data of this NumPy array in the form of values, then you can simply print it. And there you can see the data which is actually constructing this image. So our image and all the colors and data inside this image is being constructed with these numerical values. So here, as it's a NumPy array, so if you want to get a particular value which is at particular index, then you can also do that. So here firstly we are getting the value here by specifying these indexes. So let's run it, and there you can see we got this output. And if you want to get the particular value, then you need to specify 3 indexes here because it is a 3D array. So here let's run it, and we got this output here, and this is the value present at 0th index of all the dimensions of this NumPy array. So in short, when we load images in Python using Matplotlib, the images are being loaded as NumPy arrays, and then on images we can perform any operations which we can perform on NumPy arrays. So that is a basic introduction of Matplotlib library, and this library will be used for visualizing our data. Hello guys, Hamza here. I just want to let you know that this video is just the first part of my complete Train Machine Learning Models and Build Mobile Applications course. The complete course is around 20 hours long, and it includes training machine learning and deep learning models and building mobile applications in 3 different app development frameworks like Flutter, native Android with Kotlin, and native iOS with Swift. The complete course includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. Apart from that, you will get a certificate upon completion which you can add to your resume, and the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below, and we are offering a discount to first 100 students. And now let's continue to the next lecture. Welcome to this lecture. In this lecture, we will learn about a library called TensorFlow. So what is this library and why we are learning about it? So TensorFlow Lite is a library developed by Google for machine learning and AI, and it is one of the most popular and most used library of this current era. And the reason is, by using this library, we cannot just train machine learning models which run on desktop or on web, but the models trained using this library can also be used on mobile devices. And we are going to use this library for training such machine learning models which can be used in mobile, web, and desktop applications. So let's start. So the first step is opening this notebook file where we got the code for this library. So you can check the resources of this lecture or go to the course resources, and there you will find this TensorFlow folder, and inside it you will find this notebook. So you need to open this TensorFlow.notebook file inside Google Colab, and once you will do that, you will be able to see this code. And here, after opening it, the first step is importing this library so that we can use it. So to import this library, use the command import TensorFlow as TF, and then we are printing the version of the library as well. And there you can see the output. So it means that the library is imported successfully, and we are using the version 2.15.0. So after importing this library, the next step is declaring variables and constants in TensorFlow. So there you can see this next section, and here we are creating this simple Python variable. So we are creating v0 and assigning the value 42 here. So this is the declaration of just a simple Python variable. But if you want to create a TensorFlow variable, then you need to use this tf.variable function and then specify the value. And if you want to create an array in TensorFlow, then you can use this tf.variable, but this time you will specify the values of the arrays. Like here, the array contains 2 values. And if you want to create a multi-dimensional array in TensorFlow, then you can declare it like this. So you need to use this tf.variable, and then inside these curly braces you will specify the rows of your multi-dimensional array. So now let's run this cell so that all of these 4 variables will be created, and now we will analyze them one by one. But before that, click on this edit button and select this clear all outputs, and it will gonna hide all the outputs present in this notebook. And now we are going to print the value of each cell and look at the output. So firstly, let's run this v0. And we got the output 42 because this is just a simple Python variable. And after that, let's print this v1. And as this v1 is a TensorFlow Lite variable, so we got this information here. So v1 is of type tf.variable, and the shape of this variable is not defined because it contains a single value. And after that, the data type of the variable is integer 32, and the actual value of this variable is 42. So while printing a TensorFlow Lite variable, we are getting all of this information. And here, just like Python, the data type is assigned automatically based upon the value of the variable. So we defined the value 42, so as it's an integer, so it assigned the data type to integer 32. So now after printing this v1, let's print this v2. And there you can see we got the information. So again it is a variable, but this time we got the shape. So as it contains an array of size or shape 2, so we got this shape here. And after that the data type is integer 32 and then the values. So the value of this TensorFlow Lite variable is an array which contains 2 values. And now let's print v3. And this time you can see our shape is 2 rows and 2 columns because this v3 contains this multi-dimensional array. And now the value is this 2-dimensional array. So that's how you can create variables in TensorFlow, that you need to use this tf.variable and then specify the single value or the array which you want to create in TensorFlow. And after creating a variable, if you want to change the value of that variable, then you can use the assign function. So here if we want to change the value of v1 variable to 33, then we can use this v1.assign and then specify the new value. And after that we are printing v1 here. So now let's run this cell. And there you can see now v1 contains the value 33 and earlier it was containing the value 42. So that's how you can change the value of a variable in TensorFlow. And after working with variables, the next thing is working with constants in TensorFlow. So to create a constant in TensorFlow, you can use this tf.constant and then specify the value. And it will gonna create a constant here. And after that, we are also printing the value of this constant here. So let's run this cell. And now you can see the output. So here the value of this constant is 42 and the data type is integer 32. And if you want to specify the data type while creating a variable or a constant, then you can also do that. And to do that, you need to specify this dtype variable. Like here we are creating a TensorFlow Lite constant and we are specifying the data type to float 64. And after that we are printing that constant as well. So let's run this cell. And there you can see this time the data type is float 64 and the value is 62.0. And you can use this dtype parameter for TensorFlow Lite variables as well. So that's how you can create variables and constants in TensorFlow. And after that, the next step is shaping a tensor. So if you want to know the shape of a TensorFlow Lite variable, then you can use variable.shape property. So here we are creating this TensorFlow Lite variable which contains a 2D array. And then we are printing its shape. So let's run this cell. So there you can see the tensor shape is equal to 2, 3, which means that this tensor has 2 rows and 3 columns. And similarly, if you want to reshape a tensor just like a NumPy array, then you can use this tf.reshape function. And here you need to specify your input tensor and then the output shape. So now our t4 variable or t4 tensor will be reshaped into this particular shape. And then we are printing the shape again. So let's run it. And now you can see the shape of our tensor is changed. Similarly, let's print this t5. And now you can see it contains this single row with 5 items. So that's how you can get the shape of a tensor or reshape it. And after that, the next thing is ranking of a tensor. The rank of a tensor is the number of dimensions it has, and that is the number of indices that are required to specify any particular element of that tensor. And based upon this description, we can say that the rank of a tensor is the number of dimensions of an array. And if you want to know the rank of a particular tensor, then you can use this tf.rank function. And inside it, you will specify a TensorFlow Lite variable. Like above, we created our v3 variable, so there you can see that. And it is a two-dimensional array. And here we are printing its rank, so let's print it. And there you can see the rank of this tensor is 2. So similar to printing a TensorFlow Lite variable, when we are printing the rank, we are also getting this information. And here the actual value is indicated with this NumPy key. So rank of v3 is 2 because it was a two-dimensional array. And after rank, the next thing is specifying an element of a tensor. So if we want to get a particular element of a tensor, then you can get it using these indices. Like we created T4 above, so there you can see this is T4 and it is a two-dimensional array. So now if we want to get the element which is present at the 0th row and first column, then we can specify the indexes and it will gonna return that element. And then we are assigning the result to this T6 and then we are printing this variable. And basically it will gonna return the element in the form of TensorFlow Lite constant. So let's print it and you will see the information here. So there you can see the value present at that index is 2 and we are getting this tf.tensor. And we were getting this value when we were printing TensorFlow Lite constant. So here above we were printing TensorFlow Lite constants here. So there you can see this C1 and we are getting a similar message here. So now if you want to get a particular element, then you can get it like this. And if you want to cast or change the type of TensorFlow Lite variable to a NumPy variable, then you can use this variable and the NumPy function. So here we are converting T6 to NumPy. So let's print it. And you can see we are getting this information. So basically it was a TensorFlow Lite constant and now we are changing it into a NumPy value. And after doing that we are printing it and we are only getting this 2 and not all of this information. Because this information will be printed for TensorFlow Lite variables and constants. And after that the next thing is finding the number of elements of a tensor. So if you want to get the size of a particular tensor, then you can do it like this. So this T4.size and then inside it you will specify the input value. So we want to get the size of T4, which is a TensorFlow Lite variable which we created above. And after that we are using this NumPy function because we want to get the size in the form of integer or NumPy value. So here let's print it and you will see the information that the size of T4 is 6, which is correct because we got T4 here. So there you can see T4 and it contains 6 values. And if we remove this NumPy function from here and print the value again, now you can see we are getting a TensorFlow Lite constant. So here the size is 6, but we want to avoid all of this extra information. So we use this NumPy function. So let's add it again. So by using this NumPy function, you can only get the output value for a variable or constant instead of all of that information. And basically it is converting that TensorFlow Lite variable into a NumPy variable. So that's how you can get the number of elements of a tensor. And after that, if you want to get the data type of a tensor, then you can use this dtype property. So here let's print this t6.dtype and you can see we got integer 32. So these are some basic operations which will gonna help us during our model training process. And after that, the next thing is specifying element-wise tensor operations. So here we are creating two TensorFlow Lite variables, so this T7 and T8. And now if you want to divide each element of first tensor with the element of second tensor, then you can do it like this. So here basically we are dividing first element of T7 with first element of T8. And then second element of T7 with second element of T8. And after that we are getting or converting it into NumPy. So let's print the result. and there you can see our result is 0.5 and 1. So basically when we divided this 1 with 2 we got 0.5, and when we divided this 2 with 2 we got 1. And you can also perform other operations like addition, subtraction and multiplication. Like here we are multiplying T7 with 4 and then we are printing the result, and it will gonna multiply this 4 with each element of T7, and there you can see the result that now T7 contain 4 and 8, and earlier it was containing 1 and 2. So now after multiplying 4 with this 1 we got 4, and multiplying 4 with 2 we got 8. So whatever operation you are going to perform on TensorFlow Lite variables using these operators, they will be performed on each element of this variable. And after that, the next thing is transposing and matrix multiplication in TensorFlow. So just like NumPy in TensorFlow, you can also multiply arrays as matrices. So to do that, here we are creating two TensorFlow Lite constants. So firstly, we are creating this C1 with the values 1 and 2, and then this C2 with values 3 and 4. And now if we want to multiply them just like matrices, then we can use this tf.matmul. And here you need to specify both of the matrices which you want to multiply. So firstly, we are specifying this C1, and then we should specify C2. But we are not directly specifying C2 here. And the reason is, in order to multiply matrices, the number of rows in first matrix should be equal to the number of columns in second matrix. But in our case, C1 is the first matrix and it has 1 row, and C2 is the second matrix but it got 2 columns. So they cannot be multiplied directly. So in order to multiply them, we are taking transpose of C2. So in matrices, there is a term used transpose. And when we take transpose of a matrix, we are changing its rows with column and column with rows. So when we are going to take transpose of this C2, we are going to get a matrix where there will be 2 rows and 1 column. So right now there is 1 row and 2 columns, but after taking this transpose, we will get 2 rows and 1 column. And now this C1 can be multiplied with the transpose of C2, because in C1 there is 1 row and in the transpose of C2 there will be 1 column. So here to take transpose of C2, we are using this tf.transpose and then specifying the matrix for which we want to get the transpose. And after that, we are multiplying C1 and C2 here. And this multiplication is as per rules of matrix multiplication. So let's run it and you will see the result. And there you can see the result here is 11, and we got this 11 after multiplying this C1 and C2 as per the rules of matrix multiplication. So that's how you can take transpose of matrix in TensorFlow and multiply matrices. And now the next thing is typecasting. So if you want to change the type of a tensor, then you can also do that. Like here, firstly we are printing this C1 which we declared here, and there you can see its data type is integer 32. But now if you want to change this data type to some other type like integer 64 or float 32, then you can do that with the help of this tf.cast function. And here we are specifying C1 and then we are specifying this dtype variable. And here you need to specify the data type which you want to assign to this C1. So here let's run it and you will see that now C3, which is the result, contain the data type integer 64. So that's how you can change the data type of each element of a tensor. And after typecasting, the next thing is declaring range tensor. So what is a range tensor? So when we create multidimensional arrays in Python or inside any other programming language, we know that the number of columns are fixed for each row. Like if we are creating a multidimensional array with 3 rows and 4 columns, then we know that each row of this array contains 4 values because there are 4 columns. But in TensorFlow, you can create a multidimensional array where there will be different numbers of columns columns in each row. And to do that, we are going to use this tf.reg.constant function. And here inside it, you can see we are creating a multi-dimensional tensor or an array. So here the first row contain only single value, which is 1. And then the second row do not have any value. And after that, the third row has 2 values, and the fourth row contains 3 values. So you can see each row of this multi-dimensional array or tensor contain different number of columns. And that is a feature provided by TensorFlow. So here let's print this range tensor, and you will see the result. So there you can see in the result we did not get the tf.variable or tf.tensor, but instead we got the type tf.rangeTensor because it is a range tensor with different number of columns in each row, and then you can see the values. So that's how you can create range tensors in TensorFlow. And now let's look at few more operations which we can perform in TensorFlow. And the first one is getting mean of a value or mean of TensorFlow Lite variable. So if you want to get the mean of a TensorFlow Lite variable, then you can use this tf.reduceMean function. And inside it, you need to specify the variable for which you want to get the mean. Like here we specified v1, so when we will run it, we will get the result equal to 33. And the reason is we declared and initialized v1 above, and then we reassigned it to value 33. So there you can see that. But if v1 contain multiple values, then we are also going to get the mean of those values. So here let's change the variable name. So instead of v1, we will declare v2 and run it. So you will get the mean which is equal to 1. And the reason is in v2 there are 2 values, 1 and 2. And after getting the mean, we got an integer value as a result, which is 1. And if you want to get the mean of a TensorFlow Lite variable which contain multiple dimensions like a 2D array, then you can also specify the axis along which you want to get the mean. Like here we created a 2D tensor and there are 2 rows and 2 columns. And now if we want to get the mean across columns, then we will specify the x is equal to 0. So let's run it and see the mean. So the mean which we got is 2 and 3, and we get it by adding this 1 with 3 and dividing it 2, so we got 2, and then by adding this 2 with 4, so we got 6, and after dividing it with 2 we got 3. And if you want to get the mean row wise, then you can specify the x is equal to 1. So there you can see we specified it here. And now let's check the result. And there you can see we got the mean equal to 1, 3. So that's how you can take mean in TensorFlow. And now let's see how we can generate tensors with random value in TensorFlow. So random values are frequently required when developing neural networks. So in actual, when we create neural networks for training our model, the neural network consists of a lot of variables. And at start, we need to initialize those variables with random values. So there we can use these functions of TensorFlow to create those random values. So here to create tensor with random values, we can use this tf.random.normal function. And then inside it, firstly you need to specify the shape of the tensor which you want to generate. Like if we want to create a tensor with 3 rows and 2 columns, then you can specify it like this. And then you can also control the values which are being generated by specifying the mean and the standard deviation. Like if you want that the mean of the values which are being generated is 10, then you can do it like this. And if you want to specify the standard deviation, then you can also specify it with the help of this variable. And after that you can specify the data type of the variables which will be generated. So here we specified float 32. So now let's run it and look at our output tensor. So there you can see we got a tensor here and it contains 3 rows and 2 columns. And this data is generated randomly. So let's run it again and you will see different values here. So there you can see that. And if you want to create random values and you want to make sure that the random values are between a maximum and a minimum value, then you can use this random.uniform function. And here firstly again you will specify the shape, and then you can specify the min and the max value. Like if you want to make sure that the random value will be between 0 and 5, then you can specify the min value to 0 and the max value to 5, and after that specify the data type. So let's run it and see the output. So there you can see we got this output here, and there you can notice no value is less than 0 or greater than 5. Similarly, you can try these functions by adding different shapes and different ranges. And if you are generating random values and you want to make sure that the next time you will get the same random values, then you can do that by setting a seed value. So here we are using this tf.random.setSeed, and then you need to specify a value here. And after that, when you are going to run this uniform function and you are going to generate random values, you will notice that upon running this cell again and again, we are getting the same random values. So here let's run it. And now look at the values. So now when we will run it again, and you will notice we are getting the same values here. And the reason is we have set a seed, and this seed will gonna repeat the random values which were generated for the first time. So that's how you can create or generate random values in TensorFlow. And now the next step is adding two tensors. So if you want to add two tensors element wise, then you can use the plus operator here. So we created this v1 and v2 here. So now if you want to add first element of v1 with first element of v2 and second element of v1 with second element of v2, then you can use this plus operator here. So let's run it. And there you can see the result contain 5, 5, because adding this 3 with 2 we got 5 and 4 with 1 we got 5. And if you want to concatenate two tensors, which means that apart from adding the values, you want to add the rows or the columns, then you can do that with the help of concat function. So here we created two tensors and they both contain 2 rows and 2 columns. And now if you want to concatenate v2 and v1, then you can use this concatenate function, and here in the values array you need to specify the variables which you want to concatenate. Similarly here you can specify more than 2 variables as well, and then you can specify the axis along which you want to concatenate them. So here we specified the axis 0, which means that we want to concatenate them by columns. So for now both v1 and v2 has 2 rows and 2 columns, but after concatenation the resultant tensor will gonna have 2 columns but 4 rows. So let's run it. And there you can see it is concatenated column wise. So now there are 4 rows and 2 columns. And if you want to concatenate them row wise, then specify the axis 1. So let's run it. We got 2 rows and 4 columns. So that's how you can add two tensors or concatenate them row wise or column wise. And now the next operation is finding minimum and maximum value of a tensor. So here we created a TensorFlow Lite variable. So now if you want to get the maximum value, then you can get it using this tf.argmax function. So here specify the variable in which you want to get the maximum value. So let's run it. So there you can see it returned 3 here, but 3 is not the maximum value present in this array. Basically it is returning the index of the maximum value. So as 5 is the maximum value and it is present at the index 3, so it returned that index. And if you want to get the minimum value, then you can get it using this tf.argmin. So now let's run it and look at the output. So the output is 1, and the reason is in this array the minimum value is 2 and it is present at the index 1. So that's why we are getting 1 here, which is the index of minimum value. So that's how you can get minimum and maximum element of a particular tensor. And now the next section is saving and restoring tensor values using a checkpoint. So what is a checkpoint? So when we train a machine learning model, our trained model consists of thousands of variables, and that trained model is using those variables to make predictions. And while training the model, we are basically calculating the values for those variables. So in the process of model training, we are calculating the values for thousands of variables. And now while training our model, for storing those variables temporarily so that we will have the backup, we use checkpoints in TensorFlow. So a checkpoint in TensorFlow is used to store the progress of model training during our model training process. Or in other words, it is used to store the value of thousands of variables during model training. So now let's see how we can create checkpoints in TensorFlow. So here we are creating a TensorFlow variable, and now we are going to store it inside a checkpoint. And to do that, we will use this tf.train.checkpoint, and then in the parameter we will specify our variable which we want to store in the checkpoint. And after that we will call this checkpoint.save function, and then we are specifying the name of the checkpoint. So now let's run this cell, and after that this array or variable will be stored inside checkpoint. And when you will expand this files pane, you will be able to see this checkpoint here. So it created these files while storing this array. And now if you will print this save path, you will get the path here. And after that, let's assign a different value to this variable which we firstly created. So instead of this 1, 2 and 3, 4, we are going to change the values to 0, and then we are printing it. So let's run it. And now you can see our variable contain the value 0. But we have also stored the previous values of this variable inside a checkpoint. And now we are going to restore those values. So using this checkpoint.restore, and then we are going to specify the path here. And it will gonna restore the values in this variable which we stored in the checkpoint. So let's run it. And now let's print the value of variable again. And there you can see again our variable contain the values 1, 2, 3 and 4. And the reason is we have stored the state or the value of this variable inside a checkpoint, and after that we have changed the value of the variable. But as we have kept the backup or created checkpoint for our variable, so at any point we can restore that value. So here we restored the value in the variable using the checkpoint, and now our variable contain the original values. And the same mechanism is applied while model training. So we are storing the progress of model training inside a checkpoint. And after that, if while model training there is any error or any problem, then we can restore the values or the progress of model training at any point. So hopefully you got the idea about the use of checkpoints in TensorFlow. That checkpoints are used to store the progress of model training during training any machine learning model. If you want to become a mobile machine learning expert, then subscribe to this channel and get 92% off on our mobile machine learning courses. Links are given in the description. Welcome to this lecture. In this lecture, we will look at the basic introduction of TensorFlow Lite. So, what is TensorFlow Lite? It is an open source library for on-device machine learning. So, it lets you run machine learning models on mobile devices without any internet connection. So, it means that using this library, we can run machine learning models inside our mobile applications without any internet connection. So we can take advantage of this library to do classification, regression, or anything else you might want without a round trip to a server. So let's understand the use of this library with the help of an example. So let's say we want to train a machine learning model to recognize different fruits. Like we want to recognize orange, pineapple, apple, watermelon, and banana. So to train this model, we are going to collect the images of these fruits and pass them to our machine learning algorithm. And now we will get our trained machine learning model. So now this trained model can be used in desktop and web applications, but it cannot be used in mobile applications because the processing power of mobile devices is quite limited. So there we cannot perform all the operations which we can perform in desktop or web applications. So in order to use this trained model inside our mobile application, we use this TensorFlow Lite library. So with the help of this library, we convert our model into a TFLite format, and now we can use this TFLite model inside our mobile application. Similarly, you can understand the importance of TensorFlow Lite with the help of this diagram. So there you can see we got this box which is indicating a trained TensorFlow Lite model. So this is our trained model which we can use on desktop or web, but we cannot use it inside mobile. So now here we use the converter of this TensorFlow Lite library, and it converts our model into this TFLite format. And now we can use this model inside our mobile applications. Like here we can use it inside Android or iOS. And inside both applications, for using this model, we got this thing with the name interpreter. So this is a TensorFlow Lite interpreter using which we are going to load this model inside mobile application and then pass input to the model and get the output. So here there are two important things. This TensorFlow Lite converter which converts our model into this TFLite format, and then this TensorFlow Lite interpreter which is used to load the model inside our mobile application. And now let's look at the biggest advantage of this library, which is machine learning at the edge. So what does that mean? So as mentioned earlier, that by using this library we can perform machine learning inside mobile applications without any internet connection. And the reason is that our machine learning model is present in the application itself, so we don't need any internet connection to access that model. And this thing is called on-device machine learning or machine learning at the edge of the network. And there are number of advantages of this on-device machine learning. And the first one is the latency. So by latency we mean that the time needed to pass input to the model and get the output. So as now our model is present in the application itself, so we can quickly access it and get the output. So the latency of our application will be low, which means that we will get the results faster. Similarly, the second advantage is privacy. So as there is no data which needs to leave the device, so the privacy will be improved. And the next advantage is connectivity. So as our machine learning model is present in the application itself, so we don't need any internet connection to access it. And the fourth advantage is power consumption. So as we are not using any network, so our power consumption will be low, which means that our application will not be resource heavy. So these are some additional advantages which we get by using this library. And the advantage of TensorFlow Lite library is not limited to just Android and iOS. But if you get your trained model in TensorFlow Lite format, then you can also use it in Raspberry Pi microcontrollers and ARM based systems. Welcome to this section. In this section, we are going to train a very simple linear regression model and build our iOS application. So we are going to train our model on this particular dataset, and there you can see we got a single input value and a single output value. And here there is a specific pattern between input and output, and that pattern is each output is equal to 2 into input minus 1. And you can confirm this pattern by looking at these values. Like here the input is 10 and the output is 19, which we got by putting 10 here, so 2 into input minus 1, which gave us 19. And same is the case with all the rows. So that is a specific pattern inside our dataset. So as machine learning is all about pattern finding, so here the pattern is each output is equal to 2 into input minus 1. And we are not going to tell that pattern to our machine learning model, but our model will going to figure that out during training. So for training our model, we are going to take this dataset and pass it to our machine learning algorithm. And now our machine learning algorithm will find that pattern and we will get our trained model. And now that model should be able to predict values based upon this pattern. Like if we are going to pass 10 to our trained model, then our output should be close to 19, because that is the pattern inside our dataset and our trained model should be able to figure that out. So now after training the model, we are going to use this model inside our mobile application. And when we will pass input to our model inside that application, it will going to predict the output based upon the pattern it discovered while training. So if inside our application we will pass input is equal to 5, then our output should be close to 9, because the output should be 2 into input minus 1, which is 9. So if our model is trained well, then we should be able to get correct outputs based upon the input values of users. So now inside this section, we are going to train this very simple linear regression model and build our iOS application. So let's begin. Welcome to this lecture. In this lecture, we are going to train our first machine learning model of this course. And then we are going to convert that model into a TensorFlow Lite format so that it can be used in mobile applications. So let's start. So the first step is getting the code for training our model. So you need to open course resources and there go to the basic example folder. And inside it you will find this regression basic example notebook file. So just open this file inside Google Colab. And you will be able to see this code. And you can also get the code of this notebook from the resources of this lecture as well. So once this notebook is opened, you will be able to see this code. And now let's start training our first model. So to train our model, the first step is importing the libraries which we are going to use. So as earlier, we have learned about different libraries like TensorFlow, NumPy and Pandas. So now here we are going to import few. So firstly, we are going to import TensorFlow because we are going to use this library for training our model. So we are importing it as TF. And after that we are importing NumPy because we are going to use NumPy for creating our dataset. So we are importing it as NP. And then from this TensorFlow library we are importing a module called Keras. And by using this Keras module we are going to create neural networks of our model. And then we are importing this Lite module from TensorFlow, and using this Lite module we are going to convert our model into a TensorFlow Lite format so that we can use it inside our mobile applications. So here let's run this cell so that our libraries will be imported. And there you can see the execution of this cell is completed, which means that the libraries are imported successfully. And after importing the libraries, the next step is preparing our dataset. So as in the introduction video of this section, you have learned that we are going to train a very simple model where we will have single input and a single output. And the relationship between the input and the output will be that each output is equal to 2 into input minus 1. So here we are creating the dataset using NumPy, and there is the same relation between x and y. So each value of y is actually 2 into x value minus 1. Like here you can take this last value of x, so when we will multiply 2 with 4 we will get 8, and after subtracting 1 we will get 7. And same is the case with all values of y. So the relationship between x and y will be that each y is equal to 2 into x minus 1. So here firstly we are creating the x array using this np.array, and after that we are specifying the values, and then we are specifying the data type of the values, and after that we are creating the y array as well. So now let's run this cell so that our dataset will be ready. And after preparing the dataset, the next step is creating our model. So as we have learned about deep learning or artificial neural networks, so we are going to train our model using those artificial neural networks. And to do that, firstly we are going to create our neural network. And as we have learned that a neural network consists of different layers of neurons, and each layer has one or more neurons inside it. So here to create our neural network, we are going to use this Keras package which we imported from TensorFlow library. And then we are using its sequential function. And now inside this function, we need to pass an array. And in this array, we are going to specify the layers of neural network. So you can specify as many layers as you like. Like here, for now, we have specified a single layer of neurons inside this array, and that layer is created using this keras.layer.dense function. And inside this layer, we have specified that there will be only one neuron, and the input received by this layer will also be 1, so we specified the input shape equal to 1 as well. So that's how you can create a layer of neural network using Keras, and then you can specify that layer inside this array. And if you want to add one more layer, then you can simply add a comma here and repeat the same thing here, and then you can add more layers if you want. But for now, we are training a very simple model, so we are going to use a single layer of neural network, and that layer will gonna have only one neuron. So here, with the help of this first line, we are creating our neural network or our model. And inside our neural network, there is only one layer, and inside that one layer, there is only one neuron. And we are assigning that neural network to this model variable. And after that, we are calling this model.compile function. And here we are specifying two things. Firstly, we are specifying this optimizer and then this loss. So as we have learned about this loss function, that this loss function is used to calculate the difference between predicted and actual value. So when we are training a machine learning model or a deep learning model, then during training we compare the predicted values of the model with the actual values, and then we find the difference between these two values, and this difference is calculated using this loss function. And our goal is to minimize the value of this loss function as our model is being trained. So at the start, the value of this loss function will be bigger, but at the end of our model training, the value of this loss function should be smaller. And the reason is this loss function is indicating the difference between predicted and actual values. So at the end of model training, there should be very small difference between predicted and actual value. Otherwise, our model is not trained well. So that is the function of this loss function, that it is giving us the indication or the difference between predicted and actual value. And then we specified this parameter with the name optimizer, and we specified the value equal to SGD, and it stands for stochastic gradient descent. And the role of this optimizer is to update the weights of neural networks in such a way that the value of this loss function will gonna decrease as our model is being trained. So during training our model, we are passing our dataset to the algorithm, and the algorithm learns from that dataset. And while learning, the weights of the neural networks or the neurons are being updated. So this function is used to update those weights in such a way that the value of loss function will gonna decrease, or our model will gonna learn from the dataset. So now after calling this compile function, our model will be ready for training. So let's run this cell so that our model will be created and compiled. And after that, the next step is training our model. So to train our model, we are going to use this model.fit function. And now inside it, we are going to pass our data set. So firstly, we are passing the X array, which is the input value, and then the Y array, which is the output. And after that, the third parameter is the number of epochs. So as explained earlier, this number of epochs means that while training our model, we are going to pass our dataset to the algorithm 500 times. And if you are going to change the value to like 1000, then it means that during training our model, our dataset will be passed to the algorithm 1000 times and our model will be trained. So now let's run this cell so that our model training will gonna start, and it will gonna finish in just few seconds. So there you can see the progress. And there you can see in just 8 seconds our model is trained. And the reason is our dataset is very small with just few values, and our neural network is also very simple with just one layer and one neuron. And now during training the model, our dataset was passed to the algorithm 500 times. And each time the dataset was passed, you can see an entry there. So here let's scroll to the top when our model training started. So there you can see the first epoch. So this was the first time when our dataset was passed to the algorithm. And there for each time you can see the value of loss function. And as mentioned earlier that if our model is being trained well, then the value of this loss function will gonna decrease as our model training will gonna proceed. So there you can see for the first epoch the value of loss function was 20. And it was 16 for the second epoch and 12 for the third epoch. And then you can notice that for each of the epoch the value of this loss function is decreasing. And even at the end of our model training you can notice that the value of this loss function is very small. So you can see the value of loss function for the last epoch is 4.39 power minus 5. So it means that the value is decreased a lot and our model has learned from the dataset, or it has actually found the pattern inside our dataset. So now after training the model, the next step is testing the model. And while testing, we will get to know that whether our model is trained well or not. So as you know that the pattern inside our dataset was each y is equal to 2 into x minus 1. And now if our model has figured that pattern out, so when we are going to pass an input value, then we should get an output which will be 2 into input minus 1. Like here we are using this model.predict function and passing a single value as input, which is 100. So now our output should be close to 2 into 100 minus 1, which is 199. So let's run it to check the output. And there you can see our output is 198.72, which is almost 199. So it means that our model is trained quite well. Similarly, let's test it for some other value like 20 and let's run it. And there you can see our output is quite close to 39, which is the actual value. So it means that our model is trained quite well and we have verified that thing during testing. And after testing the model, the next step is converting our model into TFLite format. And to do that, we are going to use the Lite module of TensorFlow library. So here we are using this tf.lite.tflite converter from Kira's model function. And inside it, we are passing this model which we just trained. And now it will gonna give us a TensorFlow Lite converter object. And after that we are calling this converter.convert function and it will gonna convert our model into TFLite format. And after converting the model and getting it in the form of this TF model object, the next step is storing this model in the form of file. So here we are opening a file with the name linear.tflite, and here you can specify any name that you like. And we are opening that file in WB mode, and WB stands for writing in a binary mode. And we have learned this thing while covering file handling section of Python programming language, and now we are using it. So after opening this file in a binary mode, we are writing the content of this TF model inside this file. So now when we are going to execute this cell, our model will be converted and it will be stored in a file named linear.tflite. And there you can see the output. So now when you will check this files pane, you will be able to see this linear.tflite. And this is the model which we just trained and converted it into a TFLite format. And now if you want to download that model, you can simply click on this download button and our model will be downloaded. So there you can see that. And the size of this model is just 1 KB because it is a very simple model with just a single layer and single neuron. So that's how you can train a very simple linear regression or machine learning model and then convert it into a TensorFlow Lite format. So now let's simply review the process for training this model. So to train our model, firstly we imported the libraries which we are going to use. And after that we have created a very simple dataset which contain a single input and single output value. And in future when we are going to train our advanced machine learning models, then we are going to use large datasets where there will be thousands of rows inside our dataset and also multiple input columns. But for now we are training a simple model, so we got a single input and a single output. And after preparing the dataset, we are creating our neural network, and here we are specifying that we want to create such neural network where there will be one layer of neuron, and inside that layer there will be only one neuron. And after that we are specifying the optimizer and loss function. So this loss function will gonna indicate the difference between predicted and actual value during model training. And this optimizer will gonna function in such a way that the value of loss function will gonna decrease during model training. So after creating our neural network, we are training our model by passing input and output value here. And then we are specifying the number of epochs, and you can also try to change the value and check the model result because it is a parameter which will gonna affect the performance of our model. So here you can try to change the value to like 1000 and check the model performance. So now after training the model, we are testing the model here by passing the input values. And then we are converting our model into a TFLite format and writing it into a TFLite file. Hello guys, Hamza here. I just want to let you know that this video is just the first part of my complete Train Machine Learning Models and Build Mobile Applications course. The complete course is around 20 hours long and it includes training machine learning and deep learning models and building mobile applications in 3 different app development frameworks like Flutter, native Android with Kotlin, and native iOS with Swift. The complete course includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. Apart from that, you will get a certificate upon completion which you can add to your resume, and the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below, and we are offering a discount to first 100 students. And now let's continue to the next lecture.